All right. So let me make sure everybody hear me okay. Someone to check in. I want to make sure things weren't reset after the weekend and I can still hear you guys here in the classroom. One brave soul.
We can hear you.
Awesome. I can hear you guys too. Just double checking. All right. So, um, couple things before we jump into material. Uh, so we'll pick up, and I posted the complete versions of the slides for week 3. We had a couple things that we didn't get to last week, so we'll kind of start with those. So we're down here, slide 37, 38, or sorry, is where we kind of left off. We'll pick up on, oh, where is it? Moved them to the end. So let's see here, surpluses and shortages, okay? I will post an announcement later today. So the next 2 days or my office hours will be between the two sections I teach. So it'll be 12:30 to 2 instead of that hour in the morning. I will likely still be able to meet during that hour in the morning. I've got some things that I might not be able to guarantee that until the day of. So I want to make sure those are allotted hours, the hour and a half in between classes kind of match what I've been before. Also, I noticed this morning I'm getting the notifications from Zoom, and I think I have it switched over now. They were going to my spam folder. So I had if you enter the virtual office hours, and I'm not there, always, it shouldn't be an issue now, but send me an email because if you send me a direct email, I see that pop in my inbox right away. So when I'm working on other things, I just don't want you to be sitting there kind of waiting. I think I missed someone earlier today. So if you still have kind of your question you want to meet right after class, feel free to ask the question, or even this afternoon, that hour and a half time block, I'll be available as well until from what 12:30 to 2 o'clock. I will get that announcement up that those office hours next 2 days will be that during that time. We also will be having that first exam this Thursday, so that 4-hour time block where you can get on, start, and any time in between 11:15 and 3:15, although to have the full hour and 15 minutes, you'd obviously have to start at the latest at 2, okay? And I'll talk a little bit more about the logistics of the exam. We'll be doing only review on Wednesday's class. We'll finish up new material today and tomorrow. In fact, tomorrow, I'm guessing we'll have some time to even start doing some review from those practice problems, excuse me, which are under exam 1 materials. Kind of we'll start, we got the answer key, practice problems. If you have any specific ones you want to see worked through, have those ready to go, and I'll start with those. I'll probably field the class for questions. Otherwise, I'll kind of pick and choose some that I think are a little bit more difficult or I think would be valuable to see before that exam. This will be your real main source of studying for that exam. The module quizzes will be good, although because of the condensed nature of this class, quiz 3 and 4, there we go, are kind of set to be due that day, that night right before the exam, so Wednesday night. So that won't give you a whole lot of time for module 4 because we'll finish covering it tomorrow. So give you about a day and a half to make sure you kind of get on. So I would start looking at those review problems for module 4. That first half of the questions we'll have covered today. So start reviewing those now. Now that the quiz on module 1 and 2, which were due at the end of the day last night, I'll have that kind of set so you can now go back and review those and see your answers and see what the correct answers should be. But all the practice problems for every single module, those will be good study materials for the final. But if I was just going to start with one thing, that's where I would really focus on this set here. This is going to look very similar to what the exam looks like. This will be kind of your holy grail to study. Okay. All right, any questions before we jump back and finish up module 3 material here? Okay. All right, so we left off kind of talking about equilibriums, things that would shift supply and demand. So we'll now kind of think about, all right, so what if a market wasn't in equilibrium? All right, why does it arrive? And I gave a little bit of insight into this last week, but we'll think about if for whatever reason we're looking at a short run, we're not currently in the equilibrium, what could exist in these markets? So we go back, I have that same supply and demand schedule we were using with the different prices, the corresponding quantity demanded, and the corresponding quantity supplied. We could graph these out. The the first thing that could occur is if we're not at that equilibrium price. So just to remember, refresh, that equilibrium price was where every unit that was being supplied is going to be purchased, or there's a consumer willing and able to purchase that unit on the market. So quantity supplied is equal to the quantity demanded at that price of 3. That's our equilibrium price and quantity. If for whatever reason the current price was above $3, okay? So let's say the price was at 5. The current quantity demanded, and you can think of this in terms of the number of people or just the number of units one person would want. When I think about market demand, I typically talk about it in terms of the number of people that want to buy something, but it really could be the number of units as well. So let's say at $5, 9 people are willing to buy this good. And at that higher price, right? So notice going from 3, the equilibrium price, to 5, fewer people want to buy that good. But if the price was higher, more people would be willing to and able to supply it. So at that price of 5, the quantity supplied is 25. What's going to happen? Well, if there's 25 of these units produced and out there on the market, but only 9 people want to buy it, we're going to have, what, 16 laying around that no one's buying? We would call that a surplus. Okay? So we would have a surplus in the number of units. Once we get to some subsequent modules, surplus will have a slightly different meaning for us, but right now we're talking about the surplus in the number of units. All that surplus is the difference between our quantity supplied and quantity demanded. So anytime that quantity supplied is greater than our quantity demanded, we would say we have a surplus. We have got a number of units out there that nobody wants to buy or is not willing or able to buy. Okay. So what does this look like visually? So let's say I had that supply and demand, market supply and demand graphed out. If I'm at that higher price, so a price that's above my equilibrium, notice the point that I'm hitting that quantity demanded, or sorry, the point that I'm hitting my demand curve would be at a quantity demanded that is less than where I would be hitting the supply curve and what that corresponding quantity supplied would be. So that's only ever going to be true when the price is above that old equilibrium price. Okay. So I'll kind of take what we're doing on the slides here and combine it what we're about to do in a second with shortages. If this pulls for me, there we go. Perfect. So we just had one price on that graph in the slides. But if I'm looking at any market, right, we said the equilibrium price and equilibrium quantity would be where supply is equal to demand, or the quantity supplied is exactly equal to the quantity demanded at that price. For any price that's above that equilibrium, well, what do we know is going to be true? Any price above that, the quantity supplied will be somewhere out here. And any price higher than this, the quantity demanded is going to be lower. So at any price above the equilibrium, so if we have a price above our equilibrium price, what's definitely going to be true is the quantity demanded will be less than the quantity supplied, or we would say we have a surplus, right? So that's going to be true for any price above that equilibrium. Okay. Any questions on that idea? I'm going to jump the gun a little bit here. Well, go back to the slides and then we'll kind of add to this. Okay. So we've got this surplus, and I'm going to skip ahead here. And we'll then talk about shortages. And I'll go back to that other slide to kind of touch on what I wanted to get at there. So let's say I've got instead same supply, same market demand, but now I've got a price that is somewhere below the current equilibrium. So notice at this lower price of $1, 21 people want to buy the good, only 5 people are willing to supply it. So that means, well, 5 of these people will buy it, but now there's still what? 16 of them who would still want to buy that good, but no one is willing to supply it to them. So there we would call that a shortage. There's more demand than there is supply at this lower price. Okay? So what's the value of that shortage? Just like the value of the surplus, it's just the difference between the quantity demanded and quantity supplied. It's just now we know at a lower price than the equilibrium, our quantity demanded will be greater than our quantity supplied. So if we're thinking about what that looks like here, we were just looking at a price that was down here. right? So any price below the equilibrium, so if we're looking at prices that are below our equilibrium price, what's going to be true? Well, we're going to be at a point on the supply curve that's less than the point we're at on the demand curve. So if there's more people that want to buy the good than are willing to supply it, whenever the price is below the current equilibrium, or sorry, below whatever the current equilibrium price is, we would say there we have a shortage. More people want to buy the good than what is currently being provided in the market. So any price below that equilibrium, this range would represent somewhere where we have a shortage. Okay. Any questions on that? All right. Another way of thinking about this, I'll put this over here in case people are still writing things down. Let's think about if I did have, so let's say the current price was up here. I think this is what we had, like $5. And the current quantity demanded, point we're at in the demand curve, is less than our quantity supplied, the point we're at in the supply curve. We've got a surplus here. Well, if I'm selling something, if there's nobody, so, let's say this was, I think it was like 24 were being supplied, only 9 people bought it. There's going to be 16 producers who produce this good, have on the market, but nobody buys it. If nobody buys it, what's the marginal benefit of producing that good? Well, if I can't sell it, the marginal benefit would just be 0, right? So is that marginal benefit going to be above? Remember, supply represents the marginal costs. No, right? My marginal cost will be something for every quantity in this range. So what do I start to do as a producer? Yeah, if I could sell it at this price, the marginal benefit would be above the marginal cost, but nobody's buying it, so the marginal benefit is 0. So at this point, I say, well, look, I know that there's only going to be, I think the number was, 9 people willing to buy it. So I'm going to start to not produce some of these units because I know I can't sell them. Now, as the quantity supply goes down, right, what price are they willing to accept a lower price for that unit? Well, at this lower price, once there's fewer units out there, consumers are willing to pay, right? Or sorry, at this lower price, consumers are willing to buy the good at that lower price for a few more units here. Or there's a few more consumers who are convinced that I wouldn't have paid $5 for this good, but I might pay $4. Well, now notice what's happening to the value of my surplus as that price is getting closer to my equilibrium price. The value of that surplus is going down. So when we have a surplus, there's going to be downward pressure on the price because producers are going to stop producing as many units. Well, now that they're now stopping at a number of units that have a lower marginal cost, they're willing to accept a lower price. That'll push the price down. More consumers are willing to pay. That's going to occur until we get to the point where every unit that the producer is producing, they're able to sell, right? There's no longer going to be any units where the marginal benefit is 0, right? Where they're just kind of have it sitting around without a consumer willing to buy it. So anytime you have a surplus, there's going to be downward pressure on the price, okay? Very similar thing would occur. So go back to the slides here. All right. So if we do start out with a price, there we go, that we have a surplus. Well, what's going to happen? We said the marginal benefit to all of these units that aren't being purchased is going to be 0. So they start to reduce their supply. They're now willing to accept a lower price. More people are willing to buy it. That's going to occur until we get down to this point where every unit being produced is being sold. That will kind of stop at our current equilibrium. Okay. So what if there's too much demand but not enough supply? We kind of already talked about this, right? That was a shortage. So let's think about if we had an example at this lower price of $1. Now the quantity supplied is less than the quantity demanded. We're going to have a shortage in units. So if 20 people are willing to buy the good, I'm currently only producing 5. What am I going to do? Well, I'm going to try to meet that demand. I'm going to produce a few more units, but every unit in this range, I would require a higher price, right? If The only way I'm going to supply these is if that price, the marginal benefit to producers, is above their marginal cost. So for all these units, in order to provide them to the market, I need that higher price of $2. Well, at that higher price of $2, I'm now willing to provide 10 to the market. Fewer people want to buy it at that price, but the quantity supplied is still below the quantity demanded. I still have a shortage. So what's going to happen? They'll continue to increase the price, produce more units. Consumers will, not be willing to buy as many until we get to this point where every unit being produced is being purchased by consumers. We're back to that equilibrium. So it doesn't matter if we start out with a surplus or a shortage. We know there's always going to be this pressure, or that producers and consumers will make these decisions that kind of push us back to that equilibrium point. Any questions on that idea? Okay. Nothing in the chat there. Let me see how many people we have in here. About usual. Yeah, perfect. So, well, if we know the market is always going to arrive back at this point of the equilibrium, why do we even talk about surpluses and shortages? Because sometimes the government comes in and steps in, right? So we'll look more at this after the next exam, module 5 and 6, which is, sometimes the government will set a price. So what are some examples of this? One of the best examples is like in the labor market. Maybe companies would, the equilibrium price of wages is lower. What does the government do? They come in and set a minimum wage. You can't pay a price below this, right? It's kind of weird to think about there's a price of labor, but there is, right? We generally don't see as many like price controls from the government in terms of, setting a price above or below, but there are plenty of other examples. So we've got like rent. I think let's see, I've got my examples here. So I guess in the 70s, I used an old one. They capped gasoline prices. So they kept it artificially below the equilibrium. So if I keep the price below the equilibrium, what is that doing? We said any price below would cause a shortage. What did we see in the 70s with gasoline? A shortage. What about rent? Just to kind of round this discussion out. What do some areas have if they're concerned that rental prices are too high? So let's say I've got like, we'll do apartments. So I've got the quantity of apartments here. I've got rent, which is really just the price of apartments. I would have some supply and demand curve. Now, just to kind of recap from what we talked about last week, what's always going to be our supply curve? Well, as the price goes up, more and more people are willing to build apartments, maybe convert. I don't know if you've seen people like convert above their garage into a rental rate with Airbnb, things like that. So the supply, which represents our marginal costs, are increasing. And then this downward sloping demand curve represents that as rental prices are higher, fewer people are going to want to rent these apartments. So whatever the current equilibrium price is, if the government comes in and says, well, we think that's too high, we're actually only going to allow the price to be this high. We're going to use rent controls, right? We're going to limit that price. Well, what happens? Well, at that lower price, what is our quantity supplied? There's fewer people who are willing to supply these apartments or build new apartments. At this lower price, more people will be willing to rent. Well, what have we created here? If quantity supplied is now less than the quantity demanded, we now have a shortage. So what are these price controls like rent controls or these gasoline capping gasoline prices? What does that do? It's going to create a shortage. We're going to, cause companies, producers to provide less of that to the market. Yeah, more people are going to want to buy it, but there's not, in terms of apartments, is this a good or bad thing? I mean, really bad, right? We now have people who want to rent in this area. There's no place for them to live. That's going to be a problem, right? So it sounds like it's good on its face, but all right, these rent controls could actually cause homelessness, people to move from your area. If you're a town and you're wanting to bring in more people, this is going to actually cause fewer people to want to live in that area. Okay. Not fewer people that want to. There will be fewer people who want to that can actually find an apartment. I should be a little bit careful with my language there. Okay. Any question over this idea of surpluses or shortages before we jump into the next module? Okay. All right, so that should round us out for module 3. We'll then take a look here at module 4. Right? So module 4 is looking at a trait of the supply and demand curve, which is elasticity. Right? So when we start to talk about elasticity, you can think about this as what do you use the word of elastic? It's like a rubber band, right? So when we're talking about is a rubber band, is it really elastic? That means can I pull it apart pretty easily, or is it very responsive to the force applied to it? If something is inelastic, this would be like a desk. It doesn't matter how much force I put on that desk, it's not going to bend, right? So that would be really inelastic. So all elasticity means is kind of the responsiveness of something. Here we're talking about the price elasticity of demand. So this first word that we use, and I'll write this out for us here in general terms. So blank, we're going to talk about elasticity of demand a lot today, but we'll talk about some other elasticities. So here we had the price elasticity of demand, but this could be like any two words, right? X or Y. So when we say this, it's how responsive is whatever we're saying here, right? How responsive is demand, right, to changes in X, or for the price elasticity of demand, changes in price. So we'll start to talk about things like income elasticity of demand or the price of other goods. So the setup will be the same for all of them. Whatever we're saying it's the elasticity of, it's how responsive is this, how responsive is demand to changes in whatever that word we put before elasticity is. Okay. So the way in which we'll measure this, right, is not going to be just in terms of the number of units. We're going to actually look at percent changes. So I wrote this out kind of in general form, just without that percent in there. Anything that we look at when we're talking about elasticities, it's not the number of units changed, it's the percentage change. So here the price elasticity of demand would be how responsive, or what is the percentage change in the quantity demanded from a percentage change in the price. Okay. The way in which we'll measure this, or this elasticity of demand, will be whatever we want to know what's changing, right? Like what is being, or sorry, I should say this differently. Whatever is responding to the initial thing that's changing. So here it's how is the quantity demanded changing when we see a change in the price. This first word, or the initial thing that's changing, will be in your denominator. And then whatever is responding, here it's the responsiveness of demand, that percent change will be in your numerator. So the reason why we use percent changes here is because quantity and price are in different units, and we want to be able to compare the elasticity of demand for textbooks to gasoline. Well, gallons and just like the number of copies is a very different unit. When we're looking at the elasticity of demand, we want to make sure we have a unitless measure. So by taking these percentage changes, we kind of get rid of the units, right? And we can then compare across different goods. Okay. Any questions on this before we keep moving? So just to kind of give a simple example, let's say Netflix is concerned with, the number of units they have, or number of units, the number of paid accounts they have is falling, which is the number of units that they're selling, right? And, they think it's because of a recent price increase. So they look at the data and they've increased their prices by 50%. And as a result, they saw that the number of people who were purchasing a Netflix account has went down by 25%. What would be their price elasticity of demand? Well, once again, we want to take those percentage changes. The thing that is initially changing the price is in our denominator. And the thing that's responding to that change, the quantity demanded, would be in our numerator. So negative 25 was the percent change in quantity demanded. 50% increase was our percent change in price. We would have a price elasticity of demand of negative 0.5. So what's going to be true about the price elasticity of demand for every product? Well, if I increase prices, what's going to happen to the quantity demanded? What was the slope of that demand curve? Negative. So our price elasticity of demand will always be negative. That won't be true when we start to look at things like income elasticities, but for our price elasticity of demand, it follows that law of demand. There's a negative relationship or an inverse relationship between the price and the quantity demanded. Okay. So what does this really, what does the negative 0.5 really mean? Okay. Well, we can start to think about we already talked about why it's negative, but let's think about the size of this price elasticity of demand. Okay. So let's say I'm looking at my elasticity of demand, and I want to point something else out here. It's a little bit tricky. When we're calculating this elasticity of demand, we don't want to confuse it with slope, right? We'll make the comparison here in a second. There is a relationship between the elasticity of demand and slope, but it's not the same. Remember, we're doing the slope. What was on our y-axis? Price. What was on our x-axis? Quantity demanded. So when we were finding the slope of the demand curve, it was the change in price over the change in quantity. So elasticity of demand kind of flips those. It's not the same thing as slope, right? So we don't want to think about slope when we're thinking about the elasticity of demand right now. Okay? So what's going to be true about this elasticity of demand? Right? Well, let's think about something that was really unresponsive. So let's say, I don't know, ER visits, right? Let's say all of a sudden ER visits became a lot more costly, right? So there was a really large, I don't know, 100% increase in the price. Well, and there might be some people who try to chance it, but like, let's say I'm going in at, I don't know, I just, uh, I don't know, got hit by a car, right? I'm not going to try to tough it out and go home. I need to go to the emergency room. So for people who are getting hit by cars, even if the price is higher, what's going to be the percentage change in the quantity demanded if the ER increases their price? Well, I'm still going to go. I'd like to live. I'll figure out the money later, right? So we might see like almost no change in the number. Like I said, maybe there's some people who are really risky and try to go home and nurse their own injuries, but I would argue that this could even be zero, right? So notice what's going to happen when we have something where people need it, right? Or even if there's a huge increase in price, I'm going to not change how much I'm using. Well, what's going to happen to this fraction? It's going to be less than negative, sorry, before I do less than here. It's going to be really close to zero. Okay. So what would this represent? Well, something where people weren't very responsive to price changes. We would call that inelastic. Okay. So whenever there's a huge price increase and the resulting quantity change is like relatively low, we're going to call those goods inelastic. Okay. Any questions on that before I keep moving here? Okay. So the next thing we'll talk about is, and this is where it gets a little bit tricky with the negative sign, so we want to deal with that, right? Because I almost made the mistake and said it's less than 1, but it's negative. Of course, it's less than 1. We always know this elasticity measure for the price elasticity of demand is going to be negative. To make it easier to think about if something's elastic or inelastic, and also to then compare to things like the price elasticity of supply, we're going to always take the absolute value. We know that it's going to be negative, so we just care about the magnitude of this elasticity measure. So notice here, if I do that, I'm going to get what? Approximately, or I'm going to get exactly the absolute value. This would be what, 0.01 or something very close to zero. So notice anytime that percentage change in price, if people aren't responding by 100% to that price change, or that percent change in the quantity demanded is less than the percentage change in price, well, that would mean my numerator is smaller than my denominator. So what's going to be true about this fraction for the elasticity of demand? My elasticity of demand would always be less than 1 if I've got something that's inelastic. Okay. And then said differently, do this in a different color to kind of keep them separated. What if I've got this elasticity of demand, right? So remember, it's the percentage change in quantity demanded over my percentage change in price. I'm taking the absolute value. if that percentage change in the quantity demanded is greater than the percentage change in price. So this might be something like, let's say I'm thinking about gasoline. Even if the price goes up a little bit at one gas station, right, one company, well, what is everybody going to do? They're going to go buy gas across the street. There's going to be a really large, size of my arrow, decrease in that quantity demanded. So if my numerator is greater than my denominator, what's going to be true about my elasticity of demand? It's going to be greater than 1. So when there's a really large percent change in the quantity demanded from a really small percentage change in price, that would mean people are very responsive to that price change, or we would say that demand is elastic. Okay. So we're starting to think about this price elasticity of demand. Its magnitude really tells us whether or not something is elastic or inelastic. If it's less than 1, we would say it's inelastic. If it's greater than 1, we would say it's elastic. Okay. So maybe here's another way of writing this out that would kind of help you keep track of this here. So let's say I think about a continuum from 0 to, I don't know, 0.999, right? If I have an elasticity of demand that's anywhere in this range, we would say that it's inelastic. If I'm going from 1.0001 to infinity, well, that's an elasticity of demand. The percent change in quantity demand is greater than percentage change in price. We would say that demand is elastic. What about if it was exactly 1? So there, my percentage change in the quantity demanded was the exact same as the percentage change in the price. So people are like perfectly responding in terms of percentages to that price change. So there we would say that it is, we have a fancy word for this, it's unit elastic, right? For every percentage change in the price, people are responding in terms of how much they buy by that exact same percentage. If they respond less than that, they respond less than the price change, they're inelastic. Greater than that price change would put us in this range. We would say demand is elastic. Okay. Any questions on this idea before we keep on moving here? Make sure there's nothing in the chat. Okay. All right. This here for a second as we go back to the slides. So I jumped the gun a little bit. So I'll skip ahead to kind of show you what we just talked about. Here's kind of a summary of everything that we just said, kind of our 3 ranges, looking at it in a slightly different way. But if our price elasticity of demand is less than 1, that would mean that the numerator has to be less than the denominator, or the percent change in quantity demand is less than the percent change in price. We had inelastic demand. The exact same percent change in the quantity demanded to the percentage change of price, we'd have an elasticity. Anything divided by itself would be 1, so unit elastic. And then anytime the percentage change in quantity demanded, people are really responsive to even small price changes. Greater than 1 would make it elastic. Okay. So now that we kind of know these ranges, how do we actually calculate these percent changes, right? So in this initial example, where was I getting these percentage changes from? Okay. So we've got this price elasticity of demand. How am I going to get these percentage changes in the price and the quantity demanded? In this class, and there's mathematically, you could do this slightly differently. There are different methods, but all we're going to use is what we call the midpoint method. Okay. So we're going to look at a price change, and what we're going to do is say, okay, what was that change, right? And then we're going to divide it by the average. So the reason why we do that is I'm going to kind of first show you why we need the midpoint method. So if I decrease the price by $20, well, if I start out with 100, maybe it's easy to think about what's a 20% of that, $20. So that would be a reduction down to 80. But if I start with 80 and I increase the price to 100, well, how much is $20, a $20 increase from the initial starting point of 80? That would be a 25% increase. So moving in different directions, but between the same 2 prices, would actually give us a different percentage change. So when we're on our demand curve, and really what we're doing, and I'll draw this out in a second, When we're calculating this price elasticity of demand, we're really just looking at two different points on our demand curve, right? Two prices, two quantity demanded. Well, if we're moving between the same 2 points, we should have the same price elasticity of demand. Here, you can kind of see if you have a decrease or increase, you're moving between the same 2 points. If you don't use the midpoint method, we don't have the same price elasticity of demand. So what we're going to do is take whatever the change in that quantity demanded is, divide it by the average between those 2 points. That would give us our percentage change. Let's see if I have it here. No, I didn't put on this one. I'll draw it out for you then, because I think it's worthwhile seeing this. So if we have that midpoint method, we said the elasticity of demand is going to be the percentage change in quantity demanded over our percentage change in price. We're taking the absolute value. How do we calculate that percentage change in quantity demanded? We're just going to take the difference between those two quantities and then divide it by the average. How do I find the average of two numbers? I would simply add them up and divide by 2, right? So this would represent my percent change in price, or percent change in quantity demanded. To find the percent change in price, I would do the same thing, but I would take the difference in the two prices and then divide that by, well, how to find the average of two numbers, add them up, divide by 2. So this would represent my percentage change in price. Oh yeah, I'm still taking the absolute value. Okay. So this would be kind of what we call our midpoint method, right? To find those percent changes, take the difference between the 2 points, divide it by the average between those two. Okay. So that's kind of what I have set up here. I just didn't have the percentage kind of to line it up with the initial percentage on here. But you can kind of see like this is giving me my average, this is the change, this is the change, this is the average. Okay. And then we take the absolute value because we always know it's negative. Just to kind of put it in those ranges, kind of our greater than, less than signs. It's easier when everything's in a positive value. Also, down the road, it'll then allow us to be able to compare to the price elasticity of supply a little bit easier. Okay. Any questions on that before we keep moving here? All right, so let's look like an actual example here. So let's say I've got an old price of $6, and at that current price, 15 people want to buy this good. If the company increases, or actually, sorry, they decrease the price here, right? New price, they're going to go from 6 to 4, so they decrease the price by $2. Well, what's going to happen? More people are going to want to buy the good. So our quantity demanded has went up. How would I find my price elasticity of demand? Well, it's kind of hard. If I don't have percentages, it went up by $2, changed by 10 here. I don't know. Was it responsive? Was it not? I mean, $2 is a pretty large percent of a small number. 10 is pretty large, but these numbers were higher. I'm actually going to compute that, or have to plug these numbers in and compute it. So I'll take my old and my new quantity, plug those in, find the average of the two. So here I think it's kind of easy. You don't always have to write this out, plugging them in. Generally, I'll look at this and say, oh, the change was 10 divided by, well, what's the average of these two? It's kind of easy to see in this example. If I add these up, divide by 2, my average would be what, 20? So 10 over 20, right? That numerator would be 0.5. Okay. And then plug in the prices, 6 and 4. That was the change in price. What's the average of those two? Once again, you might be able to, with these easier, smaller numbers, see that it's going to be 5, or you can compute it, add those up, divide by 2, you'll get 5. So then down here, you would have what? 2/5 in your denominator, or 0.4. Okay. So here we would end up with this elasticity of demand of 1.25. What does that represent? Well, that represents that percent change in the quantity demanded must be a little bit greater than the percentage change in price, because I have this elasticity that's greater than 1. Right? That numerator must be greater than my denominator. Just another thing I'll point out here, instead of dealing with the fractions, if you actually compute those numbers, that last step, you would have what? 10 over 20 would have been 0.5. And then going from 6 to 4 would have been negative 0.4. So when you are computing that percentage change in price and quantity demanded, in the actual calculation, they don't look like percentages, but they're really just percentages in decimal form. So notice whenever that numerator is higher, really what this is telling you is when there was a 40% decrease in the price, the corresponding increase in coin demanded was 50%. So people were responding by even more than what that price change was. And then that gave us our elasticity of 1.25. Sure enough, if they're responding more than what the initial price change was, we get an elasticity above 1, and we would say that it's an elastic good. Okay. Any questions on this idea? So I just wanted to kind of add that in here. You know, you don't have to necessarily look at the decimal, but it does kind of tell us something instead of just kind of relying on those fractions. Okay. So we already talked about these ranges. We're now going to then think about, okay, now that I know how to compute these price elasticities of demand, how does that relate to our actual demand curve? Okay, so it's not the same as slope. I've already said this. They are related, but it's not a one-to-one relationship, right? You can't, you know, they're not the same value, first of all. Now, as the slope of a line changes, so will its elasticity. They are directly related, but the relationship is a little bit trickier than you might think. So the rule of thumb we can use, right? We can't use anything with the exact values, but if a curve is flatter, generally we think about that demand is going to be more elastic. And then the steeper the curve, kind of it's more inelastic, or the smaller the elasticity. So we'll kind of look at some extremes, and I think it'll help make this make a little more sense. So let's look at a completely vertical demand curve, right? Everything I've drawn up to this point, it's kind of been like downward sloping. We'll look at that in a second. But let's say I had a completely vertical demand curve. What would this really be telling us? So here, if I see a change in the price by 10%, let's say, what's happening to my percentage change in quantity demanded if I had a completely vertical demand curve? Price is going down, but people keep buying the exact same amount, right? This was the idea of like an emergency room visits, something that people need to have. It doesn't matter if the price goes up or down, the same number of people are going to go to that ER if they had some reason why they need to go to the ER. Okay? So a perfectly inelastic demand curve, right, would be that when you see a change in the price, what's the percentage change in the quantity demanded? 0. So if it's perfectly inelastic, that means they're not responding at all. Consumers are not responding at all to price changes, which would mean, what is our elasticity always going to be if we had perfectly inelastic demand? Well, 0 over anything. If we increase, decrease the price, do anything to the price, we're always going to have that percent change in quantity demand to be 0. Our elasticity would always be 0. Now, here's where it kind of shows you slope and elasticity are kind of flip-flopped. What would the slope of a perfectly inelastic demand curve be? Well, this is where when we calculate slope, it's going to be what? I've got price, quantity. If my demand curve was completely vertical, here slope is going to be the change in price over the change in quantity. What's my percent change in, or sorry, what is my change in price? It's going to be something, put any number here. What would the change in quantity always be? 0. Anything divided by 0 is going to be what? And here we still have to, sorry, we're not taking the absolute value. We're looking at slope, not elasticity. It would always be negative infinity, right? Now, is there anything that is truly perfectly inelastic? No, right? I mean, maybe like something like ER visits gets really close, but there's probably going to be, like I said, 1 or 2 people who decide, you increase the price by that much, I'm going to try to tough it out at home. So it'll always have like a little bit of a kind of downward slope to it. But if it was completely inelastic, we would have a vertical demand curve with an elasticity of 0. Now, things that start to become, they are inelastic, but not quite as, perfectly inelastic. Well, there I'm going to see that whatever my percent change in price is, the corresponding percent change in quantity demanded will be something a little bit less than that. Well, what would that imply? That would imply I have a relatively steep slope, right? So that anytime I go up see this quantity go up by a couple units, I'm going to see the Y value, the price, fall by a lot. So there I would have my elasticity of demand. That percent change in price is going to be relatively large. The percentage change in the quantity demand is relatively low. I'd have inelastic demand. This is be more generally what we would see. I doubt we would see a perfectly inelastic demand curve, but we could get something close, right? In fact, if I had something that looked like this, right? So very, very steep slope, right? But if I think about, okay, I could see a relatively large percent change in the price, and the corresponding change in the quantity demand might be relatively low. This would give me an elasticity of demand that's really close to 0 or less than 1. So this would be our kind of just a pretty inelastic good, but not perfectly inelastic. Okay. And so what are some goods like this? So I don't know if you guys know this story. It's getting a little bit old at this point, but this is Martin Scarelli. I forget how to say his last name, but he like bought the rights to some HIV pills and increased the prices by a ton. Why did he do that? Well, he knew that if you have HIV and there's only one drug company that has patent rights to the pill, you're probably going to be willing to pay whatever price they charge. So you're going to be able to sell things at a much higher price, but the amount you sell is going to not change, it's not going to go down by very much. That's a good thing if you're the company, right? So you want to have an inelastic product, right? Because then you can increase the prices by a lot, right? Jack the prices way up and people are going to keep buying about the same amount. Now, what's the other extreme, right? Maybe not as good if you're a producer. What if I had a completely horizontal demand curve? What would this tell me, right? So if I have no change in the price, if it was truly perfectly elastic, even if I don't change the price, what could happen to that quantity demanded? People could just decide to buy more or less. So I'm going to have some positive change there. Any number divided by 0 would be an elasticity of infinity. And then a completely horizontal demand curve, any curve that's flat, we would say has a slope of 0. So notice when the slope is low, the elasticity is high, right? Slope of 0, elasticity is infinite. When the slope was infinite, elasticity is 0. So they are inversely related, but it's not like a one-to-one change. If the slope goes up by 1, the elasticity changes by this amount, right? We just know that there will be some inverse relationship between them, okay? So perfectly elastic, very responsive means even from no change in price, I might see that people buy more of this good. Now, is there anything that's truly perfectly elastic? Probably not. What's probably the case is we would end up with something that is, I'll try to give you a visual here to go with it, really, really close to flat so that we could see a really small decrease in the price and what might happen if people are very responsive to price changes. So a really good example of something that's close to perfectly elastic, but not completely, would be gasoline, right? If any one company tries to lower their price of gasoline, what's going to happen? That quantity demanded is going to go from here all the way to here, right? Very small percent change in the price could lead to very large percent changes in quantity. We're going to end up with an elasticity that's not only greater than 1, but probably getting closer and closer to that perfectly elastic elasticity of infinity. Okay. And then as it becomes steeper and steeper, we would say demand is probably becoming more and more what? So if we're going, I think using the two extremes, from a perfectly elastic demand curve, the steeper it gets, it's getting closer and closer to a perfectly inelastic demand curve. So as the slope is steeper, our elasticity measure is going up, right? So maybe just to kind of think, if the slope is steeper, that elasticity, sorry, I said the elasticity is going up. If the slope is steeper, our elasticity is getting closer to perfectly inelastic. So our elasticity is getting closer to 0 or getting closer to perfectly inelastic. So I think I've got one more in the slides, just of like a regular kind of elastic, not perfectly elastic. There, whatever your percent change in price, you know that people are responding by more than that. That would give us an elasticity greater than 1. You know, relatively flat would be generally what we see for an elastic good. Perfectly flat would be perfectly elastic. Okay. Any other questions there before we keep moving? And then I skipped one. But if we ever have percent change in the price, the exact same as the percent change in the quantity demanded, this elasticity is 1. There we would have our unit elastic demand curve. Okay. All right. And if it helps to think about what the unit elastic demand would look like, it'd be almost like a perfect like 45-degree angle kind of line there. Okay. All right, where are we at on time? Any questions here before we keep moving? I don't think this should be too bad yet. Okay. All right. So I've kind of mentioned some of these things along the way with the different examples I've used, but let's start to think about, you see where we're at in time and how I have these organized. Yeah, we'll talk about this. Yeah, we'll save that. I think we'll get to that next class. So let's keep going with this. So what are some of the things, we've got all these different ranges. Let's think about what's going to make some goods more elastic or inelastic. In fact, we could be looking at the same good, right? But a different market could be these different characteristics of how, well, we'll talk through them, but it could be different characteristics of the good. It could be looking at the same good, but maybe the time to buy is different. Maybe the location is different. So what are some of the main determinants of the elasticity of demand? So the first one is going to be availability of substitutes, right? So I think this, I'll describe these kind of intuitively, right? So think about it this way. If I have something where I've got a lot of substitutes available, right? So if I have many, many substitutes for a good, so we'll do more substitutes. And let's think about an example of this. So this might be something like, oh, I don't know. If I'm choosing what to get for lunch today, I could go to a variety of, I could get a sub, I could get, you know, a Mexican bowl from Chipotle, I could get Chick-fil-A, I could get a burger from a fast food. I have tons of substitutes. So the more substitutes that there are, right, what happens if I see even relatively small percent changes in the price? Well, if somebody increases their price by a little bit, and I have a lot of other available substitutes, what is it likely my percent change in the quantity demanded is going to be? If I've got a lot of other things I can choose from, price of this one thing goes up, I'm more likely going to be to switch to these other things. So a small percent change in price could cause a really large percent decrease in the quantity demanded. There, if we're thinking about my elasticity of demand, well, a really large, oh, sorry, wrong direction. A really large decrease in that quantity demanded from a really small percent change in price, large number over a small number, this is going to be greater than 1, or more substitutes are going to lead you to be more likely to have elastic demand. Okay. And then what if I have fewer substitutes, right? So let's think about it this way. Something I don't have a lot of substitutes for. You know, if I wanted to take B251 in this semester, I'm not even sure there's anyone else teaching it, right? So if you wanted to take B251 in terms of the quantity of students that take my section versus others, if it aren't as many people teaching it, well, what's going to happen? Even if I, for some reason, was able to change the price of how much you had to pay, I can't, but if I was, right? If I'm thinking about my elasticity of demand here, well, if you need this to graduate, even if I increase the price by a little bit, about the same number of people are going to take the class. When I have fewer substitutes, I'm going to end up with a really small number over a large number. My elasticity would be less than 1, or fewer substitutes leads to the demand for the product being inelastic. So I used a kind of a goofy example there, but you can think about what also could make it so that there's fewer substitutes for my good. If I make it so that people view it as though there's not substitutes. So if for whatever reason having oh, what's a good example? I'm not like into the luxury good stuff as much, but like let's think about, I don't know, what do people really like I don't know, not Gucci. What's like an example? Like what's like the most expensive watches? Like Rolex is cheap. I know there's like way better watches, but if I can convince someone that no other watch is the same as mine, or no other car is exactly like this car, if I can convince people there are fewer substitutes, I can make my product more inelastic. Is that a good or a bad thing if I'm selling it? Well, that means I could increase the price by a lot, and I'm going to still have about the same number of people buying it. If I think about just how much money I'm making, that's really just price times quantity. We'll talk more about this relationship of elasticity to revenues tomorrow, next class, but that's going to be a good thing. I want to make my product more inelastic because then I know I could increase the price by a lot and there won't be, I won't lose very many customers. Okay? So more substitutes, right? More elastic. So examples I used, fast food or any type of thing that you're eating for lunch, brands of pop or cereal. I kind of always think about this one like many substitutes. Brands of bottled water is my go-to. Like if all of a sudden Dasani starts to, increase their price by a little bit, it's the same bottled water from Aquafina or whatever. I'm just going to switch over to that other brand. So if I have a lot of other substitutes, people are going to be really responsive to price changes. If I don't, right? So these are going to be things like if I live in an area, there might only be one electric company. So maybe I try to pinch pennies and shut the lights off a little bit more, but I still need to have my heat on. I need to have all these other things. So I'm probably going to be using, although I might decrease the amount I'm using a little bit, I'm not going to be very responsive if there aren't any other substitutes, right? I can't switch to a different electric company. Anything else where there's like only one of them? So Super Bowl tickets, this is a really good example. Like the Super Bowl always sells out. They change, they're constantly charging higher prices and they keep selling out. They have the demand that is very inelastic, right? They could probably increase the price by 50% and they'd probably still be able to sell it out. Okay. So that would be the idea that I increase the price, quantity demand, it doesn't change by much because there's nothing else that would be a substitute for that Super Bowl. Okay. Or World Cup, whatever your sport of choice is there. Okay. Any questions on that idea before we keep moving? Okay. Next determinant we'll talk about is the proportion of income that a good is, right? So I think this one's easier to think about examples. So let's say I have something that's a high proportion of my income, right? So if you're making, in college, you don't have a huge income usually, and your main expense is probably going to be like your car or where you choose to live, right? So I remember like being in college looking at rental prices and like even thinking about differences of like, oh, this is $25, this is $50 cheaper. This might age me a little bit and it won't apply to Bloomington. I was also looking at not nice apartments, but like differences in rental prices of like, oh, this is 500, this place was 550 a month. Even small changes in the price there, if it was a large portion of my income, I knew I was going to be spending most of my money on this rent, I might be really sensitive to those price changes. So even though the price was only a little bit lower for rent, that was where most of my money was going. I was going to be really, really responsive to those price changes. Okay. So even when you look at cars, you're talking about, I'll give you another example for housing decisions. People will on like $500,000 homes haggle when it comes to like negotiations to buy. They'll haggle over like closing costs of like a couple grand. That is such a small percent of the price of the house, but the percent change in quantity demanded, that a couple $1,000s they're haggling over, that could be the difference from going from 0 to 1. That's a large percentage change in the quantity demanded. So a high proportion of your income spent on something, you're going to be more elastic for those products. Okay. You could then think about something I spend a really small proportion of my income. So I'll use an example. Maybe I've already mentioned it in this class. My wife says I have like it's my greatest hits of things that examples I like to use. But I have an addiction to fountain drinks. And so let's say I go to the gas station. I want to get a 44 ounce for the day and of Mountain Dew or something. And the price instead of 50 cents is $1. Well, if the price is 50 cents, I'm going to buy one. If the price is $1, I'm still going to buy one. It's such a small percent of my income that even a large percent change in the price, right? Going from 50 to 100, if we use the midpoint method, that would be what, 50 over 70 or 50 over 75. It's like a 66% change in the price. I didn't change my percent change in the quantity demanded at all. It's a perfectly inelastic good to me, right? Because it's such a small proportion of my income. Now, if instead the fountain drink was $100 or $50 or $100, maybe that might change, how many I was willing to buy, right? But when it's a small proportion of your income, people will generally ignore large percent changes in price because even though it's a large percentage change, it doesn't really have very much impact on their life, right? My example, a 66% increase in the price of a fountain drink, well, it's still only $1, so people don't change how much they buy by very much, right? Or they're very inelastic, less elastic, okay? So when it comes to these determinants of demand, sometimes it helps for you to think of a good that would make sense to you in terms of being elastic or inelastic. So think of goods that to you there's a lot of substitutes for that you would be really responsive to price changes in. Think about a good that there aren't a lot of substitutes for you and that you wouldn't be responsive to price changes. Same kind of idea for a high versus small proportion of your income, right? Try to think of examples that connect to you. I'm trying to use some that I think might connect to some of you, or we all can maybe think of, but I think it helps to anchor yourself to have your own personalized example, okay? The final thing we'll talk about, which is where we could see the same good, and really that applies here as well. Even if we're looking at the same house, the proportion of my income that a $500,000 house would be is much different than I guess who have I seen? Yeah, Conor McGregor, right? He's balling out of control, tens of millions, probably hundreds of millions of dollars. He's not going to blink. His response to a change, a large change in the percentage change of a $500,000 home, not going to be the same as mine, right? So these could be the same good, but across different consumers, it could change whether or not it's elastic or inelastic to different consumers. So this one, we'll think about the same good, but a characteristic that could change is the length of time I have to make a decision, right? So think about this, more time or less time. So what examples do I have here? Okay, I didn't put an example. I'll give you one that I kind of like. Let's say, let's say I have to be, what do I like here? Let's say I have to be somewhere in the next 20 minutes, right? And my car is almost on empty. Well, if I have to get to whatever gas station, right? I need this good now. I've got to pay whatever today's price is. But if I know that I'm going to be driving throughout the week and I've got 100 gallons in my tank, I can take the next couple days to kind of wait and see, for a gas station that has the lowest price. So if I have more time to make the decision, I'm going to shop around a little more. I can be a lot more responsive to the current prices or to price changes that I see, right? So more time means it's more elastic. And really this kind of ties in with the first determinant is if I have more time, basically I can try to find more substitutes, right? I'll give you an example that's currently going on in my life. And you will eventually be dealing with this and kind of already are if you have a car, but I am shopping around right now for insurance, right? So car and home insurance. Well, my current policy is over at the end of the month, right? So right now, I've got a little bit more time. I can shop around throughout this next month. I don't have to just make a really quick decision. With the first company that I get a quote from, I can go to a bunch of different companies, gather information, and be really sensitive to these different prices that they're giving me, right? Any a little bit, increase in price from one company, I can go find another substitute. I can go find another company. But if my policy was over today and I need car insurance to be able to drive tomorrow, I don't have a lot of time, I'm going to be way less elastic. I'm probably going to just make sure I can get insurance so that I'm not driving illegally tomorrow. I might go out and get a quote and okay, as long as it's somewhat reasonable, I'll accept it, right? They might be charging me a price that's a little bit higher than what I think they should be, but I can't be very responsive. I need this now, right? Basically, I don't have enough time to go get quotes from several different companies within the next 24 hours, given the other things that I need to do. Okay. So this is the idea that the more time you have, and the gasoline example makes sense here as well. If I just don't have a lot of time to go shop around, right, I'm going to pay whatever the current price of gas is. If I have more time, I'm going to be able to kind of drive around this week and make sure I get that lowest price, which means that people that were keeping their price high, I'm going to reduce the quantity demanded from them by quite a bit or be very elastic. Okay. Any questions on this before we keep moving? All right. So we'll think through just a couple goods to kind of give some more examples. So this was something I pulled. Do I have I didn't put the link up there. I'll try to find the link because it's kind of interesting. But there's some companies um, that put out some different measures of elasticities that they have. And this was a summary. And I just pulled, what, 10 or so goods from it. So notice something like matches, a book of matches. First of all, not many people are using these anymore, but it's a really, really small proportion of your income. So when they were looking at elasticity measures, price elasticity measures for matches, it's really close to zero, which means that people are very inelastic, right? Now, another one which the prices aren't quite as low, but we still see that it's very inelastic are tobacco products, right? Still well less than one, or even coffee. So this is going to be an interesting point. So if I want to get a nicotine buzz, and this could be cigarettes or whatever, all these Zins and everything now, and that's not what they're called. Nicotine pouches. There you go. But if I want a nicotine buzz, I have to get a product that has nicotine in it, or a tobacco product. Now, there are tobacco-less products that have nicotine, so there are some substitutes. But if I really like just the buzz I get from a Marlboro Red, there's not going to be a lot of other substitutes for that. So fewer substitutes makes tobacco products a lot more inelastic. People aren't responsive to price changes. I think the interesting thing to me here is which of these products is more inelastic, tobacco or coffee? Coffee, which means people are even less responsive to price changes in coffee, which to me would signal these might be a little more addictive. Caffeine might be a little more addictive even than tobacco products. Right? And then another interesting one that kind of lines up with some of the determinants we talked about, airline tickets in the short run. So I forget how they differentiated this. I think it was something like you need an airline ticket that's going to be within the next 48 hours. You don't have a lot of time to shop around. You kind of have to pay whatever the current price is, which is why um, as you get closer to a date, what happens typically to airline prices? They go up. That's because the companies know you can't be as responsive to that price increase. If you want to leave within the next 48 hours, you've got to pay whatever our current price is. You can't wait around and shop around. Same kind of idea if you look at, I was actually just doing this recently, thinking about going to visit my wife's parents. If you look at Airbnb rates and you look out like a couple months, the prices aren't near as high if you look at that same Airbnb and you need to get it by the end of the week, right? So the less time you have for that product, the more inelastic you're going to be. And so these companies know this, right? So they'll increase the price because they know you're not going to be able to be as responsive if you need it quickly in the short run. Okay. And then on the flip side, airline tickets in the long run, well, if I've got the next couple months to kind of shop around, I can be really responsive to what the current prices are. So in the long run, we see airline tickets, Airbnb, things like that, a lot more responsive, right? People are much more responsive to price changes if they have a long period of time to make that decision. Um, Another one that kind of highlights some of the traits that we talked about, brand new automobiles, and they specific to the brand here. Now there are substitutes, right? However, I'll kind of make a point with this one. So there are a lot of other companies that make automobiles. So what's probably driving this price elasticity of demand the most? Well, a brand new automobile is likely going to be a large percent of someone's income. So if it's a larger proportion of your income, you're going to try to make sure that you're really getting a good deal if you want to think about it that way. So you're going to be really responsive to increases or changes in that price, right? Or decreases in the price too. You'd be more likely to buy that car. So it's likely that this elasticity is being driven by the fact that a Chevy automobile, a brand new car, is going to be a large proportion of most people's income. What is also driving this to be a little bit higher? So if I was just to look at the elasticity for brand new cars, and I didn't look at a specific brand, it would actually look like it's a little bit less, right? Because I have, or sorry, probably be a little bit higher, right? Because I don't have any other substitutes for a car. But one thing that could also be driving the fact that this is fairly, hold on, let me start over. So this is the elasticity of a brand new Chevy automobile, right? What's likely causing this to be higher than 1 is that it's a large proportion of the individual's income. What if I was just to look at a brand new non-brand automobile, just any automobile? What you actually see is the elasticity there is going to be a little bit lower because there's not a lot of other substitutes for cars. Yes, public transportation, bikes, things like that. But if I want a brand new car, really the only other substitute, it might be like a used car, something like that. And the elasticity is actually going to be a little bit more inelastic. So for a Chevy automobile, right, the reason why this might be a little bit higher or people are more elastic is because I don't have to get a Chevy. I can get a bunch, any brand. I can get a Kia, I can get a Honda. And so if Chevy specifically changes the price of their brand new car, I have a lot of substitutes. I might be more likely to substitute away. That could also be driving this to be a higher elasticity or more elastic demand as well. Okay. And then, there's ones that are kind of close to unit elastic here, housing and education. Pretty close to 1, although slightly elastic. So just some, I don't know, interesting examples to kind of talk through some more examples to kind of help anchor these ideas of the different traits that would impact the elasticity of these different goods. Okay. I chose this one specifically. It's just alcohol. I thought kind of interesting. But like if you look here, once again, you guys should not know anything about this because most of you are not 21. But blended Scotch whiskey, or just basically all your cheap whiskeys, there's no difference really between them. And so, lo and behold, if we look at the price elasticity of demand for, actually, no, that's not true. Let me go. I want really elastic goods. So I want where is it at? Here we go. If I think about like, this isn't a great example. I thought I had a category here that was just like, and anyways. So these high strength premixes, people are really elastic because there's a lot of different type companies that make them. So, a lot of substitutes, people are going to be likely to kind of be really sensitive to price changes, are very elastic. Sorry, the Scotch whiskeys one, I'm mixing this up. Things that are like really unique. So this would be like single malt whiskeys, things that like companies make that people think that this brand is significantly different than this brand, or they're a little bit higher end. Well, if there's not as many available substitutes, people are going to be a lot more inelastic or have these relatively low elasticities. But I kind of also like this example because it goes to show if you just look at alcohol drinks on the total, it looks like they're fairly inelastic, negative 0.5, or in absolute terms, 0.5 would be less than 1. But if you look at different subcategories, some of those alcohols are fairly elastic, and some of those alcohols are fairly inelastic. So even within the same category of good, alcoholic drinks, if you break this down by some alcoholic drinks have different characteristics, some of these have different prices, so different proportions of income, right? You might have very different elasticities. Or if some people view these as having fewer or more substitutes, we end up with different elasticity measures here as well. Okay. So that takes us to the end of class, right? We'll pick up on this next class. We'll revisit this idea of slope elasticity. We'll talk about even on the same curve, we could look at different elasticity measures of the same demand curve. I've got an example that we'll also look at, which is going to be how we use actual data to calculate elasticity. So I might start with this next class just so we revisit how do we actually calculate price elasticity as demand, and then we'll kind of jump into then, okay, now that we know how to calculate it in Excel, how would I calculate different portions of the demand curve? Okay. And I was completely blanking on time because we're almost to the end, and it didn't save us enough time for this participation quiz. So what I'm going to do to be nice is give you the answers, and we can walk through them starting tomorrow. So this very first one should be inelastic. Number 2 should be 0.45. Number 3 should be price elasticity of demand has a slope of 0. And then the last one, which makes it more elastic, less time to make the decision. So once again, kind of run through those. We'll work through all of these problems tomorrow so we get a little review for the quiz and for the exam. But number 1, that answer should be inelastic. 2, 0.45. 3, the slope is 0. And then 4, less time to make the decision. So I want you to kind of have, value in attending, watching these lectures. So I'm giving you the answers today because I ran myself out of time a little bit. But we will work through all of these. We will also revisit that Excel example starting the class tomorrow, and then we will finish the rest of Module 4 slides and all material tomorrow. And if we do have a little bit of time at the end, I might even start reviewing some of the practice problems specifically related to Module 4 so we kind of stay on topic. And then on Wednesday, we will be doing just review for that exam. Okay? All right. Any questions for me before we get out of here today? All right.
I
All right,
actually
so
do have a question.
yeah.
So I'm actually from your 2 to 315 class, and I joined this class.